This is Precalc section 5.4, day 1 notes. Today we're going to be talking about more trigonometric graphs. Specifically today we are going to learn how to graph tangent and cotangent. So first we're going to take a look at the parent graph of y equals tangent of t. And again, I'm getting these values right off of our unit circle. So when t is negative pi, tangent of t is 0. At negative 3 pi over 4, it's 1. At negative pi over 2, it is undefined. Negative pi over 4 is negative 1. At 0, tangent is 0. Tangent of pi over 4 is 1. Tangent of pi over 2 is undefined. Tangent of 3 pi over 4 is negative 1. Tangent of pi is 0. Tangent of 5 pi over 4 is 1. Tangent of 3 pi over 2 is undefined. Tangent of 7 pi over 4 is negative 1. Tangent of 2 pi is 0. 9 pi over 4 is 1. And 5 pi over 2 is undefined. So if you look at my graph right now, you can see that there's already these dashed green lines that I put in here. So you might want to pause for a moment, grab a highlighter, and put some highlighted lines in there where I have those lines. My graph is already counted off. So this right here is pi over 2. This is pi. This is 3 pi over 2. This is 2 pi. And then this is 5 pi over 2. So anywhere that the graph is undefined, I have this vertical highlighted line because remember, my graph can't cross those lines. Those are asymptotes. The graph is undefined at those spots. And then if I just go ahead and I start plotting my points, at negative pi, I'm at 0. At negative 3 pi over 4, I'm at 1. Then at negative pi over 4, I am at negative 1. At 0, I'm at 0. At pi over 4, I'm at 1. And so on and so forth. And this pattern just keeps repeating. In between our asymptotes. So tangent basically just kind of looks like this funky sort of curved line here. It's sort of straight right there in the middle, but it swoops down and swoops up towards my asymptotes on both ends. So when you draw these in, these are called branches. And as you draw these branches in, it just keeps repeating because just like sine and cosine, tangent is periodic. So it's just going to keep repeating. So if you are asked to graph one period of tangent would be right here. Okay, this is one period of tangent. So notice, and this is kind of critical, notice that one period of tangent our x values or our domain is from negative pi over 2 to pi over 2. And our y values go from negative infinity to positive infinity, right? And that's because those branches approach those asymptotes forever. They keep going down and they keep going up forever, so they go to infinity. So right there, that kind of red boxed in is one period of tangent t. So now let's take a look at what cotangent of t looks like. Notice that my asymptotes, they're black this time, I'm not sure why, my asymptotes are in different locations this time, and that's because cotangent is undefined at different locations than tangent is. Tangent is always undefined at the pi over 2's, whereas cotangent is always undefined at values of pi. So 1 pi, 2 pi, 3 pi, 4 pi, so on and so forth. So tangent undefined at pi over 2, cotangent undefined at values of pi. Okay, so now when we look at our graph, and again, we've got some labeling here that's been done for us, but I'm going to add a few more bits in here. So this would be negative pi. This is 0. You can see this is pi. This is 2 pi. This is 3 pi. And I have an asymptote at each of those values of pi. So then at negative 3 pi over 4, I'm at positive 1. At negative pi over 2, my graph is at 0. And at negative pi over 4, my graph is at negative 1. And then just like with tangent, this keeps repeating. In between each set of asymptotes, this keeps repeating. Okay. So then we go ahead and draw our branches, and it looks very similar to tangent. It's going to approach those asymptotes on both the left side and the right side. The branches are going to, like that. So one period of cotangent t is going to occur between 0 and pi. Notice that that is different, right? So this is one period of cotangent t. So when we talk about the interval that occurs on, that is going to occur with x values from 0 to pi and y values from negative infinity to positive infinity. So our picture frame, I guess what I want you to take away from this is that our picture frame for cotangent is different than our picture frame for tangent, or at least location-wise it's different. The period for cotangent is from 0 to pi. The period for tangent is negative pi over 2 to positive pi over 2. So if you can remember that, you're off to a great start, okay? And then beyond that, just knowing, which direction the branch goes for tangent versus cotangent, or where your asymptotes are for tangent versus cotangent. Okay, so let's talk about transformations. We can transform tangent and cotangent just like we can transform sine and cosine. The period of the parent graph for both tangent and cotangent functions is pi. It's just that for cotangent, it's from 0 to pi, and for tangent, it's from negative pi over 2 to positive pi over 2. But still, that is a distance of pi units for both of those. The period of our transformed graph, if we have a period change, is going to be pi divided by k. So when we look at the next example, it says graph the following. We have y equals 2 times the tangent of x. Notice that we do not have a k value, right? So our k value is 1, which means that our period is going to be pi, normal period. But we do have that 2 in front of the tangent, okay? And that's going to be our a value. So our a value is positive 2, which means that our tangent has been vertically stretched. By a factor of 2. So what is that going to do to our graph? Well, let's take a look. Really, it's not going to do all that much, because anything that was at 0 before is still going to be at 0 now. Notice I've already got my asymptotes sketched in. Remember that the asymptotes for tangent are at the pi over 2's, right? So this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi, this is 5 pi over 2, etc. This is negative pi over 2. So my asymptotes are already sketched in. Anything that had a value of 0 is still going to have a value of 0 because 2 times 0 is still 0, right? So these points right here in the center of my asymptotes, each period here, those are still going to be at 0. The only difference is the points that used to be at 1 are now going to be at 2 instead, okay? So if we look back at our parent graph, we used to have a point that was at pi over 4, 1. Well, now that point is going to be at pi over 4, 2 instead, and negative pi over 4, negative 2. That is the only effect that a value of 2 is going to have on this graph. So it's just going to kind of stretch out my branches a little bit, make them a little bit elongated. So the curve is a little bit more subtle because those are spaced out a little bit more, but it's still the same general shape. And that's my graph of y equals 2 times the tangent of t. I've got 3 periods graphed right there. Okay, my last example here is negative cotangent of t. Okay, once again, I don't have a k value here. My k value is 1. So my period is still going to be pi. I'm not changing my period at all. But I do have an a value of -1. That a value of -1, it's not going to change the amplitude at all of my points, but it is going to reflect this graph over the x-axis. Okay, now that's really kind of critical when we talk about tangent versus cotangent, because when you reflect cotangent over the x-axis, it will look like tangent when it is reflected. And I don't want that to confuse anyone. Because normally the branches go the other way. But because we are flipping this over our x-axis, it's going to look like the tangent graph did. Okay? Except the only thing is our asymptotes are going to be at our pi values because we're graphing cotangent. So our asymptotes are not sketched in on this one. So we're going to have an asymptote at 0. We're going to have an asymptote at pi and at 2 pi, so on and so forth, right? And normally we would have points here at pi over 2. That would be our center right there. And then we've got pi. And then we've got 3 pi over 2. So that would be the center. Here would be the center, so on and so forth. So normally we would have a point at, let's see, pi over 4, 1. So if we are reflecting that point over the x-axis, that point is going to be at pi over 4, -1. And normally we'd have a point at 3 pi over 4, -1. Well, that point is going to be reflected to 3 pi over 1, +1, because we're flipping it over. So that's why this shape looks like the shape of tangent. It's just we're graphing a reflected cotangent graph. So then I'm just going to go ahead and graph a couple more periods. And that's it. Please make sure that you watch part 2 of the section 5.4 day 1 notes to get the third and final examples for the tangent and cotangent graphing.